Hello dear viewers, welcome to TV Math Hub. In our today's session, we shall be looking at question 12 for Jinja Joint Mock. For those that are preparing for Senior 6 exams, please let's move together into this journey until you do your exams. So we shall look at question 12. It says, given the points R, S, T, and N, we need to show that the points R, S, and T are collinear. So in other words, we need to show that R, S, and T lie on the same straight line. So in order to do that, we shall look at the solution. So we are given the points R, S, T, and N. And part 1, they want us to show that R, S, and T are collinear. So we shall show this, one, by considering point the vector RS, R to S. So what will be R to S? So we need to get R to S and S to T. Then we see if we can easily express RS in terms of ST or the vice versa. So if we are in position to do that, if one can be expressed as a scalar multiple of the other, then we shall be able to say they are collinear, so long as there is a common point. And for that case, we are considering our S to be a common point. So we are considering RS. So RS will be same as OS minus OR. So OS is 11, 0, 10. Then our point R is 6, 1, and 7. So this will give us 5, negative 1, and 3. So that is what we shall get for RS. So let us look at ST. What will be ST? So S to T will be same as T minus S. So T is negative 14. We have 5, we have negative 5. And we are subtracting S. S is 11, 0, and 10. So this will give us negative 25. This will give us 5 and negative 15. So that is what we are getting for ST. So our interest is to see whether we can get one vector in terms of the other. So when you look at S of T, let us consider S of T and see whether we can get it in terms of R of S. So S of T is negative 25, 5, and negative 15. So we can see the common factor is negative 5. So when we pull out the negative 5 out of this expression, we shall remain with a 5, we shall remain with negative 1, and we shall remain with a 3 here. So what does that one imply? When you look at this and this one, they are actually the same. So this is same as having negative 5 R of S. So it is clear that S of T is actually negative 5 R of S. So you can express one vector as a scalar multiple of the other. So we are having S of T can be expressed in terms of R of S. And if this is so, then we can conclude that therefore S of T and R of S, S of T and R of S are actually parallel. So these are parallel. And since they are parallel and S is a common point, and S is a common point, since they are parallel and S is a common point, then we can conclude that R, S, and T, R, S, and T are actually collinear. And that part will be answered. So that was part 1. Now, let us look at part 2. Part 2 says we need to show that STN is a right angle. So to show that STN is a right angle, we shall show that when you get ST, you dot it with TN, you get a what? You get a 0. So to show that STN is a right angle, or the angle that is formed by ST and TN is 90 degrees, then you must show that the dot product is a 0. So our interest is to show that ST dot TN is equal to 0. So we already have our ST. We have already got our ST, and ST was negative 25, 5, and negative 15. So that is what we are having as the ST. So from here we have our ST as that. So next we need to get Tn, so we can look at Tn. So to get Tn, we shall get n minus t. So n was given, that was 3, 45 and negative 20. Then we shall be subtracting t. So we are getting n minus t. So t was negative 14, 5 and negative 5. So that is what we are having for t and n. So we have t as that and n as that. So looking at this, we shall be in position to get Tn as negative. This is 3 minus 14. That is 3 plus 14, that is 17. And 45 minus that is 40. Negative 20 plus 5, that is minus 15. So that is what we shall have. So we have 17, 40 and negative 15 as Tn. So for that case, let us see if we can be in position to get this. So let us get St, we dot it with Tn. So when we get St, we dot it with Tn. St is negative 25, this is 5, this is negative 15. We are dotting this with Tn, and Tn is 17, is 40, is negative 15. So when we do that, we shall be able to get negative 25 times 17. We shall add there a 5 times 40. We shall add there negative 15 times negative 15. So when we do that, we shall be able to get negative 425. This is 200, and this one here is 225. So when we add all these all together, we shall be able to get 0. So clearly, we shall be able to say that since st dot tn, since st dot tn is equal to 0, then we can confirm that actually stn is a right angle, stn is a right angle. So that is basically what we shall have, is a right angle. So that is the angle at T is actually 90 degrees, and part 2 will be answered. Let us now talk about 12 part B, which says find the Cartesian equation of the plane which is containing points R, S and N. So we shall look at the solution. How best can we get the equation of the plane? We use the expression, a very important expression, which says that R dot N is equal to N dot A. So the most important thing when you are dealing with the plane is to first of all know the normal to the plane. So the normal of the plane will be N. R is a general point on the plane. Then this A is a point on the plane. Now, to obtain N, we shall be using what we call cross multiplication of the vectors Rs and Rn. So we shall be looking at R as a point on the plane that we shall be considering. So looking at R as that point, we shall be using R to get the normal, and we shall do that by getting Rs, then we cross it with Rn. So we have already looked at Rs, which was 5, negative 1 and 3. So next we need to get R to N. So what will be R to N? So Rn will be same as having N, which is 3, 45 and minus 20. Then this we shall be subtracting R, which is 6, 1 and 7. So when we do that, we shall be able to remain with negative 3, 44, then this will be minus 27. So that will be our Rn. So to get the normal, we shall get Rs, we cross it with Rn. Rs cross Rn. So that will give us the normal. So let us look at how best we can do that. So we have I, we have J, and we have K. So Rs is 5, this is negative 1, this is 3, this is negative 3, This is 44, and this is minus 27. So let us see how best we can get n. So to cross multiply, we shall have I. Then after having I, we shall cross out this one. We shall delete the first row, first column. So when you delete first row, this one, and this column, you will be able to remain with -1, 3, 44, and -27. So you cross out the first row, first column where I is, and you take the determinant of the remaining entries, and that would be the determinant of -1, 3, 44, and -27. Then next, minus j, then you cross out this and this, so you remain with a 5, you remain with a 3, -3, and -27. So you are crossing out this one here, the first row, second column. So when you cross out this, you remain with a 5, 3, -3, minus 27. Then plus k, so this is k into, you cross out to the first row, third column, and you remain with a 5, -1, and then -3, and 44. So that is what we shall basically remain with. So from there, we shall have I to get the determinant for that. So this will be I into 27 minus 44 times 3, which is 132. Then minus j into, so we shall get 5 times minus 27, which will be minus 135. Then you add there, that is minus 9, and that will be plus 9. Then plus k into 4 times 44, so that will be, then plus 3, so that will give us 217. So that is basically what we shall have. So from there, we need to simplify that. And this will be able to give us I into, we shall be having 1, -105, -105I. This is minus minus, which will give us plus 126J, and this is already 217K. So this is what we shall get as our n. So this is our n, and for that we have our n as -105, 126, and 217. So having got our n, we already know this expression, that to get the Cartesian equation, we shall be using r dot n is equal to n dot a. So for that case, let us look at what will be r dot n. So r dot n, so we shall say equation of the plane. Equation of the plane is given by r dot n, which is equal to n dot a. So it's given by that. So we shall have our r is a general point, which is x, y, and z. Then n is what we have got here, 105, 126, and 217. That is what we are having. This is equal to n -105, 126, 217, and we dot this with our a, that is a point on the plane, and we are considering 6, 1, and 7. So from there, let us try to get the dot product here. This is -105x plus 126y plus 217z, which will be equal to 105 times that will give us -630. We shall be adding there 126. We shall be adding there 1519. So that is basically what we are having. So we need to simplify this and get the equation of the plane. So we are having -105x plus 126y, then plus 217z, which will be equal to, so we need to simplify this. When we get this, it will be able to give us 1015. So from this given step, we shall divide through by a common factor that will be 7. So we can say divide through by -7 to make this coefficient positive. So this will be by -7, -7, -7. So 105 divided by 7 will give us 15x. Then this will be 126 divided by 7, which will give us -18y. And this will be 217 divided by 7, which will give us -31z. So this will be equal to 1015 divided by 7, which will give us -145. So this will finally give us 15x minus 18y minus 31z plus 145 equaling to 0 as the Cartesian equation of the plane. So this is the Cartesian equation of the plane. And part B of question 12 will be answered.